Let's talk about the order of filling charts for electron configurations. And as you can see, I have a diagram shown there. This is just another way of writing electron configurations. So let's start off with hydrogen that has an atomic number of 1. Based on the diagram, we start off with 1s. And here's the 1s. Since hydrogen has 1 electron, then the configuration is 1s1. As you can see there. So let's move on to the next element. That element is helium that has an atomic number of 2. We will use the 1s orbital, as I've already circled there. Since helium has 2 electrons, then the configuration is 1s2. And the maximum number of electrons in the first energy level is 2, as you can see in that chart I have there, showing the maximum number of electrons for each energy level. So let's move on to lithium. Lithium has an atomic number of 3. So that being said, we will use the 1s and 2s orbitals. And here it is. That's the next one according to the diagram. So now that we have that circled, since lithium has 3 electrons, then the configuration is 1s2, 2s1. Now you can see it has an atomic number of 3. That's why we only added 1 more electron in that 2s. So 2 plus 1 is equal to 3. So let's move on. Now the next one is beryllium that has an atomic number of 4. So we will use the 1s and 2s orbitals once again. Since beryllium has 4 electrons, then the configuration is 1s2, 2s2. So that's 2 plus 2 is equal to 4. So there you go. So moving right along here. Let's move on to nitrogen. Now nitrogen has an atomic number of 7. So we will use the 1s, 2s, and I'm going to circle the 2p, which is next according to these arrows as you move right along on this diagram. So since we're going to use those orbitals, then since nitrogen has 7 electrons, then the configuration is 1s2, 2s2, 2p3. Now why the 3? Well, let me write that 3 again. Why the 3? Because when you add it, it's 2 plus 2 is 4, plus 3 is 7. So there you go. So now let's move on to neon that has an atomic number of 10. So we will use the 1s, 2s, and 2p orbitals, which I've already circled on the diagram. Now, since neon has 10 electrons, then the configuration is 1s2, 2s2, 2p6. I'm trying to squeeze in my numbers there, but you get the point. So that's 2 plus 2 is 4, plus 6 is 10. Now, if you look at that maximum number of electrons chart, you can see that the second energy level has a maximum number of 8 electrons in the 2s2, 2p6 part. So 2 plus 6 is 8. There's the maximum number of 8 electrons in that energy level. Now, let's move on to silicon. Now, silicon has an atomic number of 14. So we will use a 1s, 2s, 2p, 3s, and 3p orbitals. So you're moving in the direction of these arrows. So here's a 3s and 3p that we need to circle here that we're going to use. So that being said, so let's put 1s2, 2s2. Now, you know you had to fill up the second energy level with 8 electrons, so you can only put 6 here. And then 3s2, because the s orbitals can only have a maximum number of 2 electrons. Now, how many do you need for the 3p? Well, 2 plus 2 is 4, plus 6 is 10, plus 2 is 12. So 14 minus 12, that gives you 2 more electrons. Easy as that. Now let's move on to chlorine. Now chlorine has an atomic number of 17. So we'll use a 1s, 2s, 2p, 3s, and 3p orbitals, just like silicon. So I don't need to circle anything else on that diagram. So once again, you can only have 2 electrons in the s orbitals. So here's 2 here, 2 here. Now that 2p, we said second energy level, the maximum number of electrons is 8. So we put a 6, right? Now 3s, the maximum number of electrons in an s orbital is 2. Now let's count these electrons. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12. 17 minus 12 is 5, so you need 5 here. So there's your electron configuration there. Now let's move on to zinc. That's the longest electron configuration. Now it has an atomic number of 30. So therefore we will use a 1s, 2s, 2p, 3s, 3p. Now you're moving in direction of the diagram, 4s, and 3d. So that being said, once again, in the s orbitals, you can have a maximum number of 2 electrons. So automatically put 2 here, 2 here. Then second energy level, you can have a maximum number of 8 electrons. So you already have 2 in the 2s. So out of 6 here, that's 8. Now 3s, s orbitals can only have 2 electrons. 3p, now what do you do here, right? Well, let's see. We have, well, remember, according to periodic table, there are only 6 columns in the p block. So you have to make it a 6, you know that. Now the 4s, once again, let me write this again. My 6 went a little bit crazy there. So let's put the 6 there. You're trying to visualize a periodic table. You can always go back to the other videos where I use a periodic table. Now the 4s can only, the s orbital can only have 2 electrons, so you know automatically that's a 2. So 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20. 30 minus 20 is 10. So you know automatically this should be 10. So there's your electron configuration. So that's another way of writing electron configurations if you have trouble understanding how it was done through the periodic table, but I think this is an easier way. Just keep in mind, the s orbital can have a maximum of 2 electrons. So you know automatically you can fill those up with 2 electrons, and then you use your chart on maximum number of electrons right here. And what I just forgot to say is on that zinc, the third energy level, the maximum number of electrons is 18. So if you look at the third energy level, 3s2, 3p6, 3d10, 2 plus 6 is 8, plus 10 is 18. There's your maximum number of 18 electrons. But just keep all of this in mind. But see how that diagram moves? Let me erase this so you can see what I was doing. So as you can see, you're just moving in direction of these arrows like this. And that's how you know which letters are next. Just keep on going and going. And that's basically it. That's another way of writing electron configurations using the order of filling chart for electron configurations.